Okay, good morning, everybody. So we're going to talk about architecture for software-defined data center. But first of all, what I'd like people to do in the panel is just literally, I think Tom said 4 seconds, so we've got like a 4-second introduction, starting at Jesse at that end. If you could just tell people who you are, and if you want to pimp your Twitter handle or something like that, go for it.
Jesse around product strategy. Andy Warfield at ProData, co-founder and CTO.
Kelly Murphy of GridStore, founder and CTO.
I'm Dave Meyer, Brocade. My Twitter handle is DMM613.
Drew Pletcher with Cisco Systems, principal engineer. My Twitter is Pletcher.
I'm Dave Wright with SolidFire. My Twitter handle's at JungleDave.
Okay, thanks. All right, so when we're talking about SDDC, we're talking about three things. The virtualization of servers, network, and storage. And really we're talking about the abstraction of all of that hardware and putting everything into software and then applying policy and so on around that. But obviously there's an architectural decision around the technology you use and how you apply that. Starting with, let's pick software-defined storage, because that's probably one of the easiest ones for me to talk about, because storage is, I guess, my background. So if we talk about the storage side of things, architecturally, I'll start with you, Dave, because you're nearest to me and you're a storage guy, obviously. Architecturally, what features do you think have to be built into the architecture if you're delivering storage in a SDDC environment?
Sure. Well, I think it's easy to talk about APIs and automation as core to software-defined data centers and software-defined storage, and I think that's important. But actually, I think you need to take a step back and actually look at the simplicity of the architecture. Not necessarily the simplicity of what's going on under the covers, but the simplicity of what's exposed from a management perspective, and what is kind of the breadth of things that need to be managed with the infrastructure. And this applies to storage as well as other systems. Because at the end of the day, if you want to abstract the control and management of this infrastructure element, be it a storage system, a network element, compute, etc., and if you want to automate the management of that infrastructure, one of the biggest limiting factors is going to be how complex it is to manage. If you have an infrastructure element or a storage system that is so complex to manage that it needs a human brain to manage it, you're never going to be successful. There's just too much there for any higher level orchestration automation platform, especially one that is independently developed by another vendor or an open source project or something else that's trying to plug in and manage your system to be able to manage. So I think one of the things just kind of kick off is to talk about the architectural simplicity and the elegance of what's being exposed. And in a storage system, that's something like having a single global pool of protected capacity, having a single pool of performance, not having a bunch of RAID sets and volume groups and LUNs and all these little things that you have to provision and manage, but having single pools that higher level orchestration layers can easily plug into, and having the ability to consistently provision capacity and performance out of them in a very predictable fashion. Without that level of simplicity, no higher level orchestration or automation is going to be able to do a very good job.
So that means, I guess, as PhD storage admins, we're out of a job going forward in that sense. Drew, your thoughts? I mean, bearing in mind you now have your own architecture storage-wise that's built into your products now.
Yeah, I'm going to steal a little bit of a page from Mike Dvorkian. In whether we're talking about the storage piece or the application pieces, we need to understand and have the mechanisms for gathering the metadata. As we look at the range of applications and their interactions with storage over the top of the network, we have a significant range in the amount of data, the type of data, and the duration in which that's being sent. Mm-hmm. So this constantly changes with the load levels of the application interaction, and being able to understand what that is and have that as a feedback mechanism into our automation systems to ensure that we can have the available network capacity, whether it's bandwidth, additional elements, what have you, to protect, whether you're talking about big data, specific transactional, mission critical application space.
Okay, brilliant. Dave, thoughts?
Well, first off, truth in advertising, I don't know anything about storage. I really don't.
Sorry, which company do you work for?
Yeah, I work for Brocade. I work on the network side. I'm really not that savvy about storage. I'm willing to admit that, but I'm just thinking about what my colleagues here have said, and I have a kind of a different view of the world. You know, many of you know I probably, or maybe you don't, I work a lot with people and biologists and stuff trying to understand networking at a different kind of level, and one of the things we see is that actually, you know, complex systems have this bewildering, basically, complexity, and you know, I do agree that it's going to be difficult for humans to kind of deal with that, and it continues to be. But I heard Neela actually hit on something that I've been pushing around a little bit, which is much more intelligent kind of orchestration systems. I think Neela said AI. There have been breakthroughs, of course, there have been breakthroughs throughout history, but that have that allow us to use what I've heard called big data, but in other places it's called, you know, genomics or anything like that, just star-omics. It just means high throughput, a lot of data to train your systems with, and we have that now, and we have systems that do that. So I'll just give one quick example of why I think this is the case, and this is kind of the canonical example that people give, is that, okay, so there's, you know, I'm with 4 or 5 of you guys, or you folks, right? And, you know, so there's something like n squared conversations going on, so 25, right? Or maybe there's 6 of us, call it 30, 36 or whatever. So you can track that pretty well. But if you look in the hyperscale data center, there's hundreds of billions of simultaneous things going on. And the idea that somebody would write code that would just orchestrate that directly just seems kind of unreasonable, you know? And so that's why more intelligence is needed, is coming. We see it in all different kinds of places. So that's kind of one way to look at that. But I mean, I think that goes across all of the elements of the data centers right now, you know, compute, storage, security, energy, and networking.
So Kelly, I guess you'd pretty much agree with what Dave said at the outset.
Yeah, both Daves actually.
Yeah. Okay. Anything that you'd like to add on top of that you think is relevant?
I think if you go back to what the you know, the context is, which is a software-defined data center, largely driven today by virtualization. You know, virtualizing you know, compute. The problem is that it really broke underlying traditional storage. You know, the storage that sits underneath that has no context of what these applications are actually doing anymore. And as you said, there could be tens of thousands or you know, millions of things happening above that. So from our perspective, what we see is that software-defined storage should kind of create that one-to-one relationship again with the underlying application. So talking about intelligence, it's about creating intelligence about what is that workload actually trying to do, what does it actually need, and where is it going to get that from, and being able to deliver that in a, you know, in a reliable, consistent manner, and then being able to put control around that so that you can move these things, you can allocate and turn the knob and actually give it more resource if it needs to. You think about service providers trying to run, you know, tens of thousands of workloads. Having that level of control and intelligence becomes critical to actually making this work.
Okay, so Andy, I guess you've got a foot in both camps. So you know, you're software-defined networking, but you're delivering software-defined storage. So. Yeah. Do you think that there's even more benefit from having the two coming together? I mean, I guess you probably would, because you've got a product that you're selling that does that. But you know, do you think there's uniqueness? And we'll get on to Jesse, because obviously Jesse will talk about all 3 of those in a moment. But do you think there's some sort of uniqueness that you bring with an architecture that brings more of those components together?
Yeah, of course. I think in all of the combinations that we're seeing convergence between these 3 pillars, right? Compute, storage, and networking. That there's this great integration that's happening, right? So in our case, and I think you know, Dave's done some of this stuff in the past too, around working more closely with the network and some of their stuff. That the opportunities to work directly with the network as a storage company mean that you can do stuff that you simply couldn't do in the past, right? And getting to your point about putting the PhD administrator out of a job.
Yeah.
I think that the one thing that is really true about what Dave was saying is that we're building these systems that must be simple because of the scale that they're being deployed at. These systems are actually a great deal more complicated than the storage systems that we've been administering for a long time. The same thing's true on the networking side and on the compute side, right? The implementations are having to raise the bar in terms of what's inside them, and so they have to be more simple. I don't think that puts the administrator out of a job, right? I think that it changes their job. right? The storage system needs to be helping you understand which workloads are costing you a heck of a lot of money because they are uselessly eating up all of your flash, right? Or because they're, burning a lot of capacity that's quite expensive and could maybe be backed up and stuff like that. So, I think that there's a lot of opportunity for these systems to expose a different type of complexity and probably a more relevant one.
Okay, so Jesse, I guess you're trying to put everybody out of a job, apart from the guys who are doing the VMware administration. But you're coming from it from a completely converged approach.
Sure. So it's interesting. With every new generation of technology, there's always this concern of, well, somebody's going to lose their job when we innovate. And the reality is, not one point in history of IT has shown that to be the case. In fact, what happens is people can go back to focusing on what's more important, right? Moving up the stack. Instead of swapping tapes, you now do something else, right? And you can find those examples through IT history. I think one of the things that we're going to find changing over time, though, is this idea of talking about software-defined storage versus software-defined networking versus software-defined something else is inherently broken, right? What we need to be concerned about is the applications in the overall data center. So I think the presentations this morning have talked about it. It's about policy, it's about the automation, it's about those things. But it's also about finding the customer's objective, right? What is the problem that you're actually trying to solve? And in the case of the data center today, if we, your question was really about the storage. So if we pull it back to the storage for a minute, one of the objectives today is the mobility of these workloads, the applications or the VMs, or whether we want to separate those or not. And that means the efficiency of the data within the environment becomes critical as well. So if you look at some of the core architectures that become the enabling technologies, making sure that the VM has mobility and or the application can get from physical data center 1 to physical data center 2 to the cloud back, means that you have to have the inherent underlying efficiency within the environment as well to be the basis to put all those other things on top of.
Okay, so I've got an open question. See who wants to take this one. Bearing in mind the whole idea of this is to abstract abstract the functionality away and virtualize from the actual hardware. Why are we spending all of our time redesigning the hardware to make this work? Why are we having to redesign all this hardware to get this to work in the first place if we're virtualizing? Who wants to pick that one up?
I'm not sure why you would say that, actually. I mean,
why are you saying
that? Storage is,
well, how many people have we got on the panel who might be building new hardware architectures?
Who's building new hardware?
Not really. I mean, we just use standard, commodity hardware. It's just a simple building block, and I think that's the whole point of it, is that you can use this underlying building block in a way that is much more intelligent now about what you put on it, how you utilize that, how you're distributing that around the place. Okay. So it isn't about building new hardware, it's about driving down the cost of that hardware and making it a simple, scalable building block.
And I think you need to separate where the engineering is being done from how the product is being delivered. Because historically there was a lot of hardware engineering, particularly in the storage space, in actual ASICs, in system design, in very custom hardware around storage. And we're now moving into an era where most storage systems today are fairly commodity, off-the-shelf x86 servers with spinning disk or flash or whatever in it, and the intelligence is in the software. Now, a lot of storage, in fact, the vast majority of storage is still sold as integrated hardware and software, and there are a lot of valid reasons for that, including the testability and supportability of the platforms, and the ability to know and deliver a known quantity as opposed to delivering software and letting somebody else kind of figure out how to run it. But at the end of the day, I think certainly most of the people on this panel dealing with storage are using fairly off-the-shelf hardware.
I think it's important Sorry, go ahead.
I just want to say one other thing is that these are points in the design space. Things can move back and forth across the hardware-software border, and they do all the time. And it has to do with efficiency, economies of scale, things like this. I mean, just control seems to work better in software, but if it has to go fast, it'll probably have to go in hardware at some time. So things just move back and forth. And I personally look at SDN is a pretty dimensional, and including, when I say SDN, I'm including network, compute, storage, energy, and security. All of those things together, we don't have a good term for that. Things move back and forth across this boundary all the time. And that's because we're always learning and optimizing for either CapEx, OpEx, or both.
Mm-hmm. Yeah, I agree. It's a point in time question, right? And we can see these cycles where it was easier to implement day one, so it was done in software, then it became optimized in hardware, then the Intel CPUs got faster, and there were certain types of acceleration got put into the CPU, and algorithms come back. The other thing is software-defined versus virtualized are two different things, and I think at times the idea of running an application in software is a distraction from the whole software-defined aspect of it. So if we look at most servers, I'd be willing to bet today that folks are deploying have a 10 gig NIC in them. Nobody thinks of that as being enabled by hardware. We think that it's just a 10 gig card, but if you weren't using the accelerators on that 10 gig card, you can wave goodbye to all the CPUs and all your performance in your host as well, right? Your performance would plummet and your CPU utilization, your host would go through the roof. So I think there's, I think it was actually Steve Harrod a couple years ago during a VMworld kickoff had a slide up that said it's software enabled, hardware accelerated, right? All these systems are leveraging flash, they're leveraging technologies to make themselves faster.
Mm-hmm. Okay, so effectively, although we may be creating new technologies like that, we're actually reusing commodity components to achieve that. So we are actually doing what we said we would do.
I think it's even more significant than that, in that for a long time to innovate, especially in enterprise networking and storage, you had to go cut some ASICs, right? You needed to, cluster controllers or build your own data path or whatever. And to do that today, in almost every situation, is going to put you behind what you can buy in commodity, right? So on the SDN switching side, Intel bought Fulcrum a couple of years ago, right? They took that chipset, they produced a 10 gig top of rack switch. They built a reference model of it, and then they released the schematics to Open Compute. Right, and this is happening to lots of stuff on Open Compute. And all of a sudden this year, there are a bunch of vendors that are selling that pretty much exact switch. Right, it costs around $7,000 list for a 10 gig full bisection bandwidth top of rack switch. Right, so to have set out to build that thing on your own would have never hit that point as fast. Right, so all of the real innovation that's happening in terms of enterprise is effectively tracing this very, very high rate deployment of great commodity hardware that's revving super fast and building software that gets power out of it.
Mm-hmm. Okay, so so Drew, can we talk about standards? Standards for how we deploy this technology, and how standards should be, whether they're open standards and standards should be part of this. What's your thought on that?
Well, some of the key drivers and what we've got to deal with from a standards perspective is going to be the interoperability, especially as we talk across multiple vendors, multiple platforms, multiple sets of APIs. We need to have some commonality in how these communicate, how they're going to work together. The direction around open standards, as we talk about, whether we're looking at open compute, open networking, even open daylight, as we're getting into a much greater embracement of open standards that everyone can work towards to provide that interoperability across multiple platforms.
And do you think the standards are stronger in the networking side than, say, they are on the storage side of things?
I mean, I'm not significantly deep in the storage side.
Dave,
I think on the storage side, you've got a lot of maturity on standards for the actual data transfer in the data plane. Where there's a lack of standards is on the control plane, which is suddenly very important in the software-defined storage world if you actually want to be able to provision, manage, control, and report on your storage in an automated way. And I think that we're seeing evolving approaches to that. I think one of the ones that I'm most interested in is kind of a counterpart to the Open Daylight project on the kind of broader software-defined data center, which is OpenStack, and what's going on with the Cinder project related to storage there, particularly because it provides a standard abstraction for, in this case, block storage to be used under virtual machines, but it provides a standard set of APIs and interfaces that vendors can then write plugins to, because there isn't a single standard to actually talk to and manage the storage systems to actually implement that. And so I think it's evolving, and we're kind of getting this kind of community effort in the open source community around storage management, within the bounds of the OpenStack project, but potentially something that could be used broader as well.
Okay.
Yeah, so one comment though is from the vendor side is that we definitely need to step up and operate at a much faster level in developing the standards, getting the standards in place.
Dave, you're going to say something?
Yeah, so there was, I don't know if you guys follow this, but there's this big eruption of this whole topic in the blogosphere last week, because what's her name? From Google wrote a blog called Why I'm Not Writing Internet Standards Anymore, or something like that. I wrote a couple of things about it. But it's actually kind of an interesting thing, because what you see in the open source world is sort of this, it's characterized by this incredible, fantastic acceleration. Things are going so fast. And if you've done IETF like I have I started working in the IETF in like 1990, right? So I've seen it a little bit. And it's pretty slow. And it's really not functioning at the same, what I would say, at the same velocity or acceleration as what we see in open source. So the question that we all have to answer here is, if we think about the IETF as probably one of the fastest standards making bodies, certainly as compared to something like the ITU or something, or it's 3GPP or something like that, right? So the question is, what is the relationship between the open source world, where standards, somebody mentioned this, standards become de facto, right? Because you have code, right? And that standards world, and I think we haven't, as a community, really figured that out yet. Mm-hmm. And there's some real...
It's interesting how the open source world is taking the place of the dominant vendors like IBM.
Yeah,
We've always created de jure standards, and then everybody copied them. That's always de facto standards.
Yeah.
And that's always been faster than the de jure process.
There's also some impedance mismatches. Like, for example, in the IETF, we like to have 2 interoperable implementations. And as I wrote last week, what exactly interoperates with OpenStack? And does that question make sense? Then, on the other hand, you have Heartbleed. So, of course, that's a whole different set of issues, but nonetheless.
Jesse, you going to say something?
Yeah, it's very challenging when you have innovative technology companies that are trying to innovate as fast as possible, and you have standards that are not necessarily trying to innovate as fast as possible. I think there's another place where you have a mismatch there. If it's faster to write the code and deliver a product than it is to get a standard defined which you would write the product to. So I think if you define the right underlying architecture to such that when a standard eventually forms that you can plug into that environment, that's a more reasonable approach. For any younger company, defining some standard and sitting on a advisory board and getting a whole group of folks to agree on some aspect of the infrastructure like that, you'll still be sitting there years down the road, and it's not a practical approach.
Mm-hmm. I would add that you probably wouldn't be sitting there, you'd be dead.
Yeah.
I mean, the reality is you've got to be commercial about what you're delivering. If you look at, there are major vendors out there like VMware, somebody mentioned in their earlier presentation, that has whatever 70-80% of the platform ownership around virtualization. So that's a de facto standard starting to emerge on its own, and they're starting to control, how things actually are orchestrated. Other things will come along, and standards will try and provide choice to that. But ultimately, it's about what people buy and consume, and that creates a de facto standard. It's happened in the past multiple times. If you look, it'll happen again.
Well, even with VMware, VAI, they said we're going to make these SCSI extensions.
Doesn't always work.
And
absolutely.
Then T10 blessed them. That sometimes having something work will get it through the standards organization
A lot faster.
Yeah.
than the ridiculous politics of, and if you're a small vendor, the big guys who are on that committee already are going to slow it down just to kill you.
Yeah.
So you've got your own private microphone now, Howard.
Howard just pulled that out of his pocket.
Well, since my laptop died, I can't be distracted, so I might as well join the conversation.
Okay, so taking it back to some of the bits and pieces that we think we might need in there, and how we deliver some of those architectural pieces. I'm really interested in the hardware side of things, and whether we think things like the Open Compute project will have a big impact on how this is delivered. Anybody like to step in and talk about that one? Go ahead, Dave.
Yeah. When I talk about open source inside my own company or wherever else I am, I always include hardware, because we came to hardware later in open source, mostly I think because the barrier to entry is just a little bit higher. you know, I mean, the barrier to entry in the open source world is like pretty low. You don't even need infrastructure, right? You just do it out on EC2 or someplace like that, right? So the barrier to entry there is somewhat lower. I don't have to build anything that, at least any physical artifact, right? So that's one thing. But I'll just say that, you know, my sense of it is, when I was at Cisco, people used to always get, I had this picture of a reptile and a human brain, and I said, you know, things are getting smarter, they're all software. And of course, all the execs went berserk whenever I showed that picture. And I showed it at Brocade too, and the same thing happened. But my argument there is that there will always be special networking kind of places, and again, I don't know that much about storage, so I'll just talk about networking here, where there is a role for custom silicon, for the high-end custom silicon. So core of the network if there are places where you can't scale out, or maybe high touch edge if you've deluded yourself into thinking you need QoS or something like that. And you know, where you can't do it on you know, a Broadcom or whatever, or where you can't do it on a Fulcrum. And there will always be those kind of places, because as the edges become more capable, the core has to become more capable. So I think those places will remain places where you'll need custom hardware. I think the rest of it around the edges are probably is probably gonna go to open compute, more open platforms over time.
But even so, the point you're making is that in the core you need specialized hardware because there's no volume, right? There's no economy of scale. Is that what you're saying? That?
Yeah, I mean, you know, if I'm going to build a router that's going to sit in the core of the internet, you're probably not going to be able to do that on a Broadcom chip.
So there's a paper at SIGCOMM last year by Google talking about their internal WAN, right? This is the B4 paper.
Yeah.
Right? It's SDN-based switches,
yeah,
built out. It's more traffic than they take externally.
That's a very specific. I'm kind of a little bit.
How is that different than building your own hardware?
How's it different than what?
Building your own hardware.
What's the point you're trying to make? I'm not following it.
You're saying that for these niche applications, right, the really high volume stuff,
yeah,
right, that there's going to be, you know, still a big market for building custom hardware.
Not big. I mean, how many CRSs can you sell in the world? You know, the big giant ones.
I'm just saying that the win of commoditization in these areas is even being applied in those smaller spaces, yeah, right? That SDN is winning there.
No doubt. No, I'm just saying that I'm just saying that, you know, if you talk to a service provider who's really sitting in the core of the internet, they need some big iron right now to afford it.
But I think it's important to differentiate between building your own hardware in the sense of getting really low level and making your own ASICs, making your own chips, I mean literally making your own silicon, is one form of building your own hardware. Another is taking off-the-shelf commodity components, CPUs and motherboards and NICs and other things, and assembling them in a form factor that is your own form factor. And that's a lot of what Open Compute has done, is make these kind of open source form factors that are based out of commodity components. And I think it's an interesting project. I think a lot of the applicability today is to some of the web scale companies that have, frankly, kind of odd needs, at least versus the general enterprise in terms of their balance of storage and compute and exactly how they build their infrastructure that's very specific to the types of applications and use cases they have. They're not general purpose enterprise use cases. At the end of the day, I think off-the-shelf commodity x86 servers in all of the different form factors that are available serve the needs of a lot of business applications just fine. But when you get into some of these really unique web scale type internet applications, they do need different form factors.
So that's an interesting one. You could just talk about the different form factors. Now, there's some of you on the panel who are doing things that are still the old style technology, like storage and server, but then it's evolving to become more converged and more merged. Do we really think that there's a long-term future for those things to stay separate? Or because we're virtualizing and the hardware is all becoming the same, is it all just going to merge into one?
I don't know about one, but I can see a lot of ways where, switching, like what we call switching today, and compute can be more tightly coupled over time. And probably storage too, in the same way.
Yeah, if you look at the last couple of years, you've seen a lot of changes in some of the ASIC capabilities. If we look specifically like at the technologies that deal with PCIe extensibility, this allows me to bring the connectivity into storage closer into the Ethernet switching. As we look at some of the discussions that are going on within Open Compute, we see radical changes in what you're going to do within rack. Utilization of technologies like silicon photonics, to where I can just have an entire fiber infrastructure within the rack and then just connect, whether it's storage, memory sleds, flash sleds, CPU cartridges. That gets you into a much different position in how you aggregate and bring all that technology together. On top of that, though, comes the software components and what you're going to develop to manage to drive that, to monitor it, and incorporate that as a feedback mechanism into the overall network infrastructure for delivery of the applications.
I think just as you were describing there's at the web scale, there's almost a trend to disaggregate these components. So you've got CPU, you've got flash, you've got network, and you've got smart software that can tie that together. And it's kind of going back to the same story about the commodity hardware. There's lots of components. If you squeeze them all together into one physical thing, you lose all that flexibility. You lose the ability to just use software to define what you want. When you take it apart and you can tie it together, use these commodity building blocks. Today we talk about appliances as that block. In the future it could be literally down to CPUs and memory and flash and these elementary components that are again tied together as you need them.
Yeah. And the disaggregation, at least in the discussions today, are disaggregating within the rack, but it's to gain an operational and economic efficiency.
Yeah.
That's it.
Yeah.
I think it's an economic question at the end of the day, right? I mean, the reason the open computer and you're seeing so many appliance-based systems come out on what are traditional server platforms is simply pure economics, right? Those platforms are much more cost-effective. Yeah. If someone, it would be really cool to build a brand new platform that allowed me to have pluggable CPU modules and high-speed interconnects to let me put whether it was flash or DRAM or other sorts of cool interconnects in there. But the cost of developing that chassis and that infrastructure is so high. When you look at the cost to just deploy some sort of high-speed interconnect between what are effectively off-the-shelf commodity server chassis, the economics are very, very different. And I think if we got to a point where the economics favored building these big giant chassis again, by all means, it's a great idea. But if that starts to look like big IBM systems or big Sun systems, Power and Spark and things like that are while still here, not necessarily the dominant infrastructure anymore. Right?
So I think this platform is, it's arguably here today, and in a better form, it's less than 2 years out. Right? We already see from Supermicros and Quantas, right, similar packaging to the two server boxes that everybody's been building appliances off of for the last 5 years. Boxes that have 8 machines in 3U, right, or 20 machines in 4U or whatever. And with the move of PCIe flash to NVMe flash to caddied NVMe flash, you have a backplane on that box that is caddied flash. So you got CPU in the front and flash in the back. Yep. Right?
Going back to kind of the original question though about if all of these things, if compute and networking storage are kind of all converging on these standardized x86 platforms, should you just run them all in the same box? Because that's really when we're talking about converged infrastructure, that tends to be what people think about as well. My box runs my storage, my compute, it's got some networking capabilities in there, and I just cluster a bunch of these things together, and I've got my data center in a collection of these boxes. And you have to ask the question of just because you can do that, should you do that? And I think at certain scales there are advantages to do that, but there are trade-offs as well. You lose flexibility, and what Andy talked about earlier is particularly you get into questions about the right balance of compute to networking to storage. And if you have a single platform that you're trying to put all of these things into, can you achieve the right balance today? And can you evolve that balance over time as your needs change? And it actually makes it more difficult if you can't scale all those elements independently. And so I think really what we're moving to is a world where, yes, all of these things are built on standard commodity elements, commodity switching chips, commodity Intel CPUs, commodity chassis and hardware. The intelligence is primarily in the software that's controlling these things, but that doesn't necessarily imply that it all has to be running in the same box, because there is a lot of flexibility and agility gained from having these be separate elements that can be scaled and deployed independently.
So even if we are going software defined, we're still building on the old style constructs of network, storage, server, and continuing to deploy on that. Is that what we're going to continue to do?
I think so, and I think there's a lot of good reasons to have those things be independent, because not every environment has the same requirements of those three things in the same quantities. Some applications environments can be very storage-centric, other ones very network-centric, other ones very CPU-centric, and every balance is going to be different. And you can either try to build a magic box that can do all of those things and has a bunch of different varieties to achieve the balance, or you can do what we've traditionally done, which is have well-defined interfaces between compute, networking, and storage, and allow data center operators to build the infrastructure to suit their use case and their environment's needs.
So do you think, and this is an open question for anybody to pick on, do you think then that we're too infrastructure focused? Because all of our conversation is infrastructure and not the application and how we run it?
I think we're very focused on this idea of the networking, the storage, the server, the this, that, and I think those lines are blurring. I think if you ask an end user, what's the most important thing? It's the application that runs the business, right? And being able to define a policy that protects that application and delivers the level of service that they want for the application is really nirvana, right? I mean, that's when I hesitate to use the word cloud, but as we talk about these, the idea of cloud, oftentimes it comes down to, well, it's easy because I can just say I want this application to go run. That gets you away from having to worry about all these underlying components that make up the infrastructure for that application. And I think moving forward, we'll see those lines blur more and more. The idea that the interconnects are fast enough so that we don't have to think so much about the interconnects, at least within a local area environment, and that whether the storage is in this system or the next system or the CPUs are here or there. I mean, if we look back pre-VMware, the idea of having memory and CPU in these islands didn't seem that broken. Now to look back and think about the idea of memory and CPU islands seems prehistoric, right? And I think that we're going to see the same thing over time with the other aspects of the infrastructure.
Yeah, but I think the reason we're so focused on the infrastructure in this panel is it is an architecture panel, right? And it's the question of what is the architecture that's underlying the software-defined data center. Now, once you have this wonderful, highly automated, highly scalable software-defined data center, the focus can be on the applications and how to deploy them and how to manage them. But the question is, how do you build an infrastructure under the covers that gives you the scalability, the agility, the automation, the flexibility, all of these things so that you don't have to then focus on the infrastructure. That's the whole point, is to design an architecture for the data center, for the software-defined data center that is simple and scalable enough that you can just focus on the application layer because you have a set of resources underneath that can be software provisioned and assigned to the applications as needed. And so there is a lot of complexity that goes into building that architecture underneath, but at the end of the day, it is about delivering simplicity to the application.
Yeah, Chris, I would add to that when I talk to large customers, it depends on who you're talking to, right? You've got application owners and you've got infrastructure owners. The infrastructure owners think about giving a container to somebody that can run an app. They have 10,000 or tens of thousands of these containers, and they don't know what's actually in them. But what they want to be able to give you is a promise that the container will do this. Performance, latency, throughput, whatever it is. If it's not enough for that application, I can turn a knob and increase what that container can actually do. And that's the kind of control that they're looking for. That's how you can actually operate at real scale. Right? If you're having to worry about how everything is actually working together, it won't happen. If I can just give you the right container and turn that up or turn it down, and I can make a promise that it will do what I said it will, then everybody's happy.
If we take a page from the Hyperscale, kind of along those lines, is that one of the things that makes them very successful at what they do is very tight work between the infrastructure teams and the application teams as they roll out new services, as they roll out new operational models, is understanding the impact of the application communication characteristics on top of the hardware infrastructure, impacts of scheduling and arbitration and buffer structures, and how they are impacted by the application and how they impact the application itself. It is something that we're just now starting to see make its way into some of the larger enterprises as they're dealing with more complex applications.
I think that's the point, though, is that hyperscale data centers are typically very specialized workloads that don't vary that much. When you get into enterprises, there are workloads that are just scan the whole spectrum. So they need a lot more flexibility. And you can be very specific about how you're going to design that infrastructure. So if you think about search as an example, very, very well defined. They can understand the characteristics of that. If you look at somebody like a Citibank, they've got 25,000 engineers just keeping the lights on.
No, understand.
They've got a complete mess of stuff.
But search is just one application. If you look at like the social media, whether you're talking about Twitter, you're talking about Facebook, you're talking about controlled chaos. And it's not necessarily a well-known, or you wrap their arms around, this is how the application behaves.
It's a different problem, absolutely, at scale.
Yes. But even if you look at the large banks, what they have in their risk machines, where you're talking about, tens to hundreds of thousands of machines within their compute grids, they run into the same kind of issues that you have within the hyperscale. But it's not so much how hyperscale operates as much as the model that they use to understand how they build out their infrastructure, and then how they're starting to develop the whole SDN model to deliver that.
Yeah. They absolutely want to get there. Same concept.
And those are the pieces that we see today being driven into the enterprise. And that starts with an understanding of components that actually sit at the host, and gathering application level information and doing correlation between application information, all the various flows, looking that into what's happening on the edge switch, what's happening as you start moving into the core. Some of the challenges that they run into, as well as we see in the enterprise, is that how the transactions, how the communication in some ways is masked. We have had a lot of work that goes on to optimize kernels, to optimize utilization of the host. And we've seen many cases where we have these transaction-based applications that do nothing more than push tens of thousands of transactions a second through a single long-lived TCP session. So what we end up having is tens of thousands of mice running around inside an elephant. So we have to understand from the edges looking in what is actually happening at the input point into the network, instead of looking at things purely from a network perspective, because we're going to not see what's really going on. And that's the change that the hyperscale environments are really bringing into their visibility from a software-defined perspective, being application-driven.
It's the visibility and the ability to control that environment then.
Okay, so we're coming towards, I guess, the last. Well, we're on the red color now. So I guess everybody about 30 seconds summing up. So Jesse, if you've got any more comments you'd just like to add, starting at your end.
But I think the one thing I'll mention a bit in my presentation, I'll just give a brief comment on here, is we haven't mentioned the application and whether the application was written and targeted to run in a software-defined infrastructure, or whether it was a traditional enterprise app. I think that's a giant variable that often gets overlooked in this discussion. I'll talk about that a bit more this afternoon.
Mm-hmm. Okay. Andy, anything more to add?
Yeah, I think
we wrap up.
I'll look forward to that. The points that the other panelists are talking about right now around these applications, there are two very different sets of applications being discussed here, right? There's the stuff that you run in your small to mid enterprise that are very unambitious, right? Kind of by definition. If your app runs in a VM, right, it is defined by the resources you can give to a VM. It may need a lot of cycles, but it gets 2 or 3 CPUs, right? 2 or 4 CPUs. Then there's these things that the Googles and the Facebooks and the Twitters of the world have built, where because of scale, they couldn't run them in a VM. And they had to go and look at how to build storage and how to build networking for those things. And so I think maybe to take a step back and talk about the applications, one useful insight is that all the stuff we're seeing now in terms of enterprise virtualization, whether it's for storage or networking or compute, is scaffolding, right? It's to let those old things run while we get to somewhere else.
Okay. Kelly, anything further to add?
Yeah, I think it's actually a very good point. If you look at enterprise, they're trying to emulate where web scale companies are going. They're seen as the innovators and the leaders, but they are different. And you need to be able to adapt to that. And the key driver behind that is virtualization, which is all about greater utilization, greater flexibility, and more efficiency. So that's really the context, I think, that anything to do with software defined needs to operate in right now.
Okay.
As you go this way, there's less and less to say, so you guys are
Well, there's also less and less time. So that's
so that's a feature, not a bug. I'll just be quick. I agree with what my colleagues here have said. I'll just say that what I usually say is a little bit stronger than what was said here, is something to the effect that today's hyperscale is tomorrow's enterprise. So remember that all this stuff, everything has to scale.
Yep. Same page, 100%. It's one change too that we really haven't talked about that I think the enterprises need to really take a hard look at is the change in what we've historically known as the network engineer, who's only been concerned about the hardware, the protocols. This new generation of network engineers we see today are more software driven than they are hardware driven. They're coming in place with programming skills, Python, C, and the ability to deal with the programmatic methodologies in which they manage the networks, manage the processes, and gain significant levels of operational efficiency.
And you've got no time at all, Dave.
No, it's okay. I'll wrap up real quick.
Yeah.
So, I think if, fundamentally answering the question of the panel of, how does the architecture need to change as we transition to the software-defined data center? We've kind of had this path from the siloed data center and siloed infrastructures, a 10-year trip through virtualized infrastructure and now into the fully software-defined data center. Does the infrastructure need to change? Does the architecture need to change? And how does it need to change? And I think the answer is yes. And it needs to change for two reasons, because the software-defined data center introduces two key elements that haven't necessarily been present before. One is much larger scale, and the other is multi-tenancy, and a very deeper level of multi-tenancy than simple virtualization. And that drives a new set of architectural requirements around scale out, around quality of service, around multi-tenant security, around APIs on automation that at best were nice to haves previously and now are absolutely required.
Okay, right. Well, thanks everybody. Thank you for all your insights. I guess we're not taking questions at this stage, Tom. Are we doing
Actually,
it later?
we do have just a couple minutes for questions if anybody has something. Oh, and I got a hand. I love that. You're right there.
Brave gentleman.
Yeah, how many layers in the OSI model? I propose we change it from SDN to software-defined datagram forwarding until we address the rest. Any comments on that?
No. Well, I'll give you one quick one. Oh, go ahead.
No, go for it. I'm not sure what you're asking.
Well, everything that's been mentioned so far about networking has only really been about layer 2. We've got as far as VLANs working up the stack. But obviously, SDN should be about solving time to market and time to react problems in my data center. So how quick as a business unit owner can I roll out an application? And if someone tells me, I can spin up your VLANs, that's not going to get me sign off from application security people, from XML transformation from server to server services, Web 2.0 type applications.
Sure, but
so there's a big gap.
Yeah, that's totally fair. But let's give that VLAN fix its due, right? If the thing that you're asking for is to spin up a SQL cluster with a bunch of web front ends and some app logic in the middle of it, and it needs to be on an isolated network, and you don't have enough VLANs, an API that lets you carve that out is a pretty useful thing, don't you think?
And I think you're seeing people working
at DevOps. Until now, but surprised we haven't. That's obviously going to be a key part in the trigger of when.
I totally agree with you, but it's
And realistically, there are people working at every layer in the network for software-defined networking. Certainly, there's lots of activity at layer 2. There is layer 3 SDN activity, and layer 4 through 7 as well. A lot of software-based networking, application networking capabilities that can be deployed in a cloud-type fabric now. So I think we're seeing all of that happening.
Any further questions?
Anyone? I have a microphone. So
we have another one down here. So.
All right.
You need to work quick. You need to move quicker.
Hi.
It's on.
Oh. I guess at the risk of sounding controversial here, who says the enterprise wants to emulate hyperscale? It certainly is not my read of talking to enterprise customers. Scale and the equipment you pick for a particular level of scale varies wildly. If I need to build a data center with 1,000 servers, Cisco UCS might be a great choice. If I need to build one with 100,000 servers, it's not even a consideration. And so I guess I hear this often from vendors, and I've got to wonder It is more a desire to be able to take provider solutions and sell them into the enterprise world than it is that the enterprise is really thinking about the problems in these ways. And in fact, I'll give you a real world example. SDN controllers. Why has the enterprise not adopted them? What I hear primarily, it solves a problem they don't have, multi-tenancy. Gives them isolated multi-tenant layer 2 networks, great. Except most enterprise guys go, I got a single tenant in my data center, me. And so why do I need this? And so I'd like to hear your thoughts on this.
Yeah, I'd like to take that. I would agree with you 100% on that. You know, that's part of the point is the workloads are very different, the needs are very different. But if you look at where the commonalities are, it's about getting better efficiency, flexibility. You know, somebody mentioned here time to market, so being able to react quicker to changes in your business. But there's no question that the workloads in an enterprise are so diverse compared to the workloads in hyperscale companies. So the needs are different, but there's commonality as well in terms of trying to get more efficiency, better economics, better flexibility.
So goals are common.
Yes.
Well, and actually,
solutions, absolutely.
The way that I would draw it is I think that enterprises probably aren't honestly looking to emulate generally the hyperscale guys like the Google and the Twitters and the Facebook. If anything, the guys they should be trying to emulate are the service providers. The folks like the Rackspaces and the Amazons and the Savises and the Terramarks. The guys that actually are very, very good at running diverse application workloads for multiple tenants at scale in a service-like fashion, and I think that's what ultimately IT departments should aspire to. And you mentioned the question of whether they have one tenants or multi-tenants. Certainly most large enterprises that I talk to, they have multiple tenants because they have multiple business units and they have to have isolation between them. And previously they'd accomplished that through physical means, and this business unit has this stack over here, and this business unit has this stack over here, and this business unit has this stack over here. But if they can actually move towards an infrastructure that looks more like a service provider, that through a software-defined data center approach allows them to get the much broader efficiency, scalability, multi-tenancy, security that the service providers have in their own data center, what that's going to ultimately deliver to them is an infrastructure that's more agile, more efficient, that they can react quicker to business needs, and really help their end users and their business customers get what they need faster.
There's a big difference in terms of multi-tenancy when you talk about organizations within an enterprise administrative domain versus customers to a provider where they've got to ensure that they have a truly isolated network. And why? Because they're managing. You know, the VLAN structures may overlap, the addressing structures may overlap, there's regulatory and compliance issues. And so to say that a enterprise has those same problems of a service provider, you know what, 4,000 VLANs is plenty for most enterprises I talk to, and having that kind of isolation is fine from a security perspective because they're not independent organizations. Now, are there exceptions to that? For sure. There are enterprises that are service providers like Fidelity that needs to serve up 401ks to a whole bunch of their customers. So that's a special case, right? But I guess I just don't see that same level of problem space. That's what I'm struggling with.
Yeah, again, I think it's a question of, which direction are they closer to? They're moving closer to the service providers than they are the hyperscale guys, because that's just a very specialized set of applications and use cases there.
So, Tom, have we got time for any more questions?
I think we have time for one more question from this gentleman. Okay. But we will also be having a Q&A session right after lunch, and I will make sure that all of these guys stick around to answer your questions because I'm locking the doors and not letting them out.
That's what that box of hand comes from.
Yeah, thank you so much. I know we are talking about data centers here, but I just want to see, what is the SDN story for campus networks? Is SDN equally applicable to campus network, or is it just for data centers?
I'd like to take that one.
The networking guys.
I think the networking
everybody's looking at the networking guys.
Take it. Thinking time.
Well, I've seen a lot of campuses that want to deploy SDN, but what I can't really understand is, kind of to your point, is I can't really understand if it's because they think that they'll get a gain perhaps in terms of commoditized hardware, software, and all of that, or if they have a use case that other than that's driving it. Because as this gentleman pointed out, at smaller scale, maybe the mechanisms we have now that are well understood are at least part of the answer. I don't know if it's the whole thing, because I don't know if the kind of agility, like the enterprises I've seen don't generally have the kind of agility that they want to have. And maybe that's, maybe that can be improved through SDN type techniques. Whether or not they have to go through this whole thing where, okay, now I'm going to have complete separation of control and data, I'm going to have this new entity controller. That's really, that's shaking out right now in my mind.
Okay.
So they're talking about implementing SDN in the campus, but I don't see a use case.
Well, so if I just had to guess, I would say it's that particularly campus networks have a problem of network device sprawl. They have lots and lots of these devices all over the place that, at least historically, have been very independently managed. I log into this switch here, I log into this Wi-Fi router here, et cetera, et cetera. And if you see the popularity of the move to cloud-managed infrastructure, particularly on the wireless side of things, I think it is driven by the same desire, which is, look, I don't want to manage 10,000 individual devices, I want to manage my network. And SDN is another way to kind of get that paradigm of, you know what, I set up these switches, they log into the SDN controller, and I can manage my network now instead of managing all these end devices. And I think particularly in a campus environment with a lot of diversity, that's probably what people are trying to get to one way or another.
Okay, well, thanks to the panel, and I'll hand it back over to Tom. Thanks, guys.
Thank you, gentlemen. We appreciate it, and let's give them a round of applause.